Good morning. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about non-preemptive multitasking scheduling algorithm. One of the scheduling algorithm is shortest job first scheduling. Non-preemptive scheduling means whenever the currently executing task is completed, then only a new process which is available in the ready state is scheduled for execution. Next, shortest job first scheduling means the process which is having less execution time, that is scheduled for execution first. We will check one example here. So let us consider three processes P1, P2, P3. With estimated execution time or completion time 10 milliseconds, 5 milliseconds, 7 milliseconds. Enter into the ready state in the order P1, P2, P3 at the same time, at the time of 0. Calculate the waiting time and turn around time for each process, and also calculate average waiting time and average turnaround time. Here we need to assume that there is no process waiting for input data or output data. In this point of view, we can calculate waiting time, average waiting time and average turn around time. So here, as we already discussed about, first, whenever any task is created that contains particular ID, like process P1, P2, P3, like that. Whenever that process is ready for execution, then the process is entered into the ready state. Ready state. Here, the device contains the scheduler. The scheduler always check the ready state. What are the processes which are available in the ready state that needs to be scheduled for execution. So, based on the scheduling algorithm, here scheduling algorithm is non-preemptive shortest job first scheduling algorithm. Whenever particular process is scheduled for execution, that is enter into the running state. While doing the execution, if the process is waiting for resources, it is enter into the wait state. After waiting some predefined time, still the process doesn't get the resources, means that process enter into the blocked state. After getting the resources, that process enter into the ready state again. So like that, that process is scheduled for execution. After completion of execution, the process is enter into the completed state. So first you are considering three processes P1, P2, P3 with execution time 10, 5, 7 milliseconds. milliseconds. So we write the timing diagram. So at the time of 0, the scheduler checks the ready state. What are the processes available in the ready state? So P1, P2, P3 available. As per scheduling algorithm, shortest job first scheduling means which process is having less execution time, that is scheduled first. So P2 is having less execution time, so that is scheduled for execution. Since it is non-preemptive until its completion, then only a new process is scheduled for execution. So its execution time is 5 milliseconds. At the time of 5 milliseconds, again, so P1, P2, P3. So first P2 is entered into the running state. So after execution time 5 milliseconds, P2 is completed, then it is entered into the completed state. Next, at the time of 5th millisecond, again the scheduler checks the ready state. What are the processes available in the ready state? So P1, P3. So among these two, as per scheduling algorithm, which process is having less execution time? P3 is having less when comparing with P1. Its execution time is 7 milliseconds. Means 5 plus 7, 12 milliseconds as a timeline. Okay, again P3 is come to the running state, it's completed, then it is coming to the completed state. Again, at the time of 12th millisecond, so what are the processes available in the ready state? P1 is only available, so that is scheduled for execution. P1, its execution time is 10 milliseconds, means 22 milliseconds. So from this diagram, we can calculate waiting time for process P1. Process P1 is entered into the ready state at the time of 0 and it is scheduled for execution at the time of 12th millisecond for getting CPU. So this process P1 waiting 12 milliseconds in the ready state to get the CPU. That is 12 milliseconds. Next, waiting time for process P2. Process P2 enter into the ready state at the time of 0th millisecond and it is scheduled for execution at the time of 0th millisecond itself. So it is waiting 0 milliseconds. Next, waiting time for process P3. Process P3 enter into the ready state at the time of 0 and it is scheduled for execution at the time of 5th millisecond. So process P3 waiting 5 milliseconds in the ready state to get the CPU. That is 5 milliseconds. So average waiting time for this requirement is sum of all these waiting times 12 milliseconds by total number of processes. .67 milliseconds on an average. Next, turn around time means the time taken by the process which is entering from ready state to the completed state. So turnaround time for process P1. Process P1 enter into the ready state at the time of 0 and its execution is completed at the time of 22 milliseconds, including execution time as well as waiting time. Totally 22 milliseconds. Next, turn around time for process P2. Process P2 enter into the ready state at the time of 0 and its execution is completed at the time of 5th millisecond. Total 5 milliseconds. Next, turnaround time for process P3 is P3 enter into the ready state at the time of 0. Its execution is completed at the time of 12th millisecond. So total duration is 12 milliseconds. So average turnaround time, that is equal to sum of all these turnaround times by number of processes. Totally 13 milliseconds. So for this requirement, if you follow the scheduling algorithm, the average waiting time is 5.67 milliseconds. Average turnaround time is 13 milliseconds for this requirement. Shall we take one more example with the same thing? Let us consider 3 processes P1, P2, P3 enter into the ready state at the same time, the order P1, P2, P3 with execution time 10, 5, 7 milliseconds. Let us consider a new process P4 with execution time 2 milliseconds enter into the ready state after 2 milliseconds. Means after starting the execution, any process, after starting the execution of processes, a P4 is entered into the ready state with execution time is 2 milliseconds. So for the same scheduling algorithm, that is non-preemptive shortest job fastest scheduling. In this algorithm, we can calculate the average waiting time and average turnaround time. So first, at the time of 0, again here ready state, running state, completed state, waiting state or blocked state. Okay. So at the time of 0, generally CPU contains scheduler. The scheduler checks the ready state always for scheduling the process as per scheduling algorithm. Here scheduling algorithm is non-preemptive shortest job for scheduling. Non-preemptive means once complete the currently executing task, then only the scheduler schedules a new process for doing its execution. SJF means the process which is having less execution time, that is scheduled first. That is shortest job first scheduling. So among this process at the time of 0, what are the process? P1, P2, P3. These three processes only available. Among them, which process is having less execution time? That is P2. Since it is non-preemptive, after completion of P2, then only a new process is scheduled. So its execution completed at the time of 5th millisecond. For understanding purpose, after starting the execution means 2 milliseconds. P4 enter into the ready state. So P1 running state completed, then come to the completed state. Again, here P4 enter into the ready state. So what are the processes available now at the time of 5th millisecond? P1, P3, P4. Among them, which process is having less execution time? That is P4. So that is scheduled for execution. Since it is non-preemptive, after completion of currently executing task, then only a new process is scheduled for execution. That is its execution time 2 milliseconds. So 5 plus 2, 7 milliseconds. Next. P4 enter the completed state. Again, at the time of 7th millisecond, what are the processes available? P1, P3. Among P1 and P3, which process is having less execution time? P3. So its execution time is 7 milliseconds, 14 milliseconds. So P3 enter into the running state and it says it's completed. Next it comes to the completed state. Next, again remaining process P1, that is scheduled for execution. P1 execution time is 24 milliseconds. So now, waiting time for process P1. Process P1 enter into the ready state at the time of 0 and its execution is completed. So it is scheduled for execution at the time of 14th millisecond. So the process P1 waiting 14 milliseconds in the ready state to get the CPU. So 14 milliseconds. Next, waiting time for process P2. Process P2 enter into the ready state at the time of 0 and it is scheduled for execution immediately. So it is waiting 0 milliseconds. Next, for process P. P3 is entered into the ready state at the time of 0 and it is scheduled for execution at the time of 7th millisecond. Okay, 7 milliseconds. So how much time it is waiting? 7 milliseconds. Next, waiting time for process P4. Process P4 enter into the ready state at the time of 2nd millisecond and it is scheduled for execution at the time of 5th millisecond. So it is waiting 3 milliseconds in the ready state to get the CPU. Okay. Now, average waiting time is equal to sum of all these waiting times by total number of processes. That is 6 milliseconds. So for this requirement, the average waiting time is 6 milliseconds. Next, turn around time for process P1. Turnaround time means the time taken by the CPU to complete its execution from ready state to completed state. So P1 is entered into the ready state at the time of 0 and its execution is completed at the time of 24th millisecond. So total time is 24 milliseconds. Next, turn around time for process P2. So P2 is entered into the ready state at the time of 0 and its execution is completed at the time of 5th millisecond. Total 5 milliseconds. For P3, P3 is entered into the ready state at the time of 0 and its execution is completed at the time of 14th millisecond. Means total duration is 14 milliseconds. So next P4. P4 entered into the ready state at the time of 2 milliseconds and its execution is completed at the time of 7th millisecond. Total time is 5 milliseconds. So average turn around time for this requirement is sum of all these things milliseconds. So for this requirement, if you are using the scheduling algorithm, the average waiting time is for each process 6 milliseconds. The average turnaround time for each process is 12 milliseconds. So you can compare with the different scheduling algorithms for particular requirement. So which process, which scheduling algorithm takes less average waiting time and less average turnaround time, that is best suitable for that requirement. So for this topic, you can refer the textbook is Introduction to Embedded Systems by Shibu KV, published by the Tata McGraw-Hill, 2nd edition, 2009 published. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.